Today we're going to find slopes of linear equations. Linear equation, linear comes from line, and it just means this equation makes a straight line on a graph. And here we have some function that gives us these 2 points. When x is 1, y is 1. When x is 5, y is 3. And so the slope is, we normally call it m. That's just convention in math. The slope is m. And the slope is a fraction. And we make that fraction out of x movement on the bottom. That's a gain or a loss in x and a gain or a loss in y. So delta y means a change in y. Delta x means a change in x. And we can look at this graph here and we can see that from one point to the other, we can see what happened with x and what it did to y. Well, if I'm at 1 and I increase by 4 x's, that gives me this distance right there. And that's really what the slope is. It's a distance over a distance. Well, my x distance is 4. That means that I increased by 4. There's a change in x of 4. And what did that do to y? Did it stay the same, or did it increase, or did it decrease? Well, y went from 1 to 3. That created a distance of 2. And that's all the slope is. And then this, of course, reduces to 1/2. That is my slope for this line. All the slope says is that if I am at some point on this line and I gain 2 x's, so I gain, this is positive, so it's going to the right. This is positive, so it's going vertical, up. Y is always vertical, so it's going up. If this was negative, it would go down. If this was negative, it would go to the left. But if I'm at anywhere on the line, for every increase in x of 2, I get 1 increase in y of 1. And that would give me another point. If I increase 2 more x's, I increase another y. Increase 2 more, 2 over, 1 up, 2 over, 1 up, 2 over, 1 up. And so the slope tells you how to find all the other points very quickly if you are already on a point. Well, the slope is easy to figure out if you're staring at a graph. But what if you were given a worksheet that said, okay, here's the points, 5 and 3, find the slope. And there's no graph here. There's nothing to look at. So all you have are these 2 points, and you're supposed to use pure math to figure out what the slope is. Well, there's a formula for that. And but first, let's just think kind of manually. How do we do this? Well, what would be the mathematical way of figuring out this distance? We don't have a graph to sit there and count. How do I know the difference, the distance from 1 to 5? Well, that is actually going to be, and so our slope is going to be this. What if I do 5 minus 1? Well, that equals 4. This is a distance of 4. That's how you find a distance on any number line. Big number minus little number always gives you a distance. Okay, what about y? So what we did just now, we used this x and this x. This x minus this x gives us a distance of 4. Okay, what about this y and this y? Because that's what this distance here is. Well, if I take big Y minus little y, 3 minus 1, okay, that gives me 2. And my slope is, again, the same as I got graphically looking at the graph, at the picture, and it reduces to 1/2. So what did we do? Well, we took one y minus the other, put that on top. That gave us a distance for the change in y, and then we took one x minus the other x and put that on the bottom, and it gave us the horizontal change in y. And so our formula is simply 1y minus the other on top and 1x minus the other on the bottom. You'll see this formula all the time. But there's one more thing lacking in this formula. This y is not the same as this y, and this x is not the same as this x. So we put little subscript numbers here. It doesn't really matter what they are, but we just do that so we can call this y1 minus y2, and it's clear that this y is not the same as this y. Some people put 0 and 1. You could put 2 and 1 instead of 1 and 2. It doesn't really matter as long as it's clear that they're different values. But what you do want to do is just like the 3 and the 5 here that came from this point, and the 1 and the 1 came from this point. Well, you do want to make sure that you use the same subscripts for this because it means the same point. You could call it point 1, and then we're subtracting point 2. So don't put 1 and 2 and then 2 and 1 if you write this formula. Okay, let's do another one. So graphically, we can look at this and we can see, okay, so if I'm at this point and I'm going to go to this point, well, what's the distance in x? What's delta x? Well, we can count it. 1, 2, 3, 4, 5, 6, 7, 8. X movement always goes on the bottom. And then what changed with y? Okay, because x was at -5 and we increased it up to 3. What did that do to y? Well, y was here at -3 and it increased up to here to +4. And what's the distance? 1, 2, 3, 4, 5, 6, 7. So our slope is 7/8. However, what if you were just given the points and no graph? So you're just looking at these 2 points here. And you have to figure out the slope with no picture to look at. Well, that's where we use our formula. Just take one y minus the other and one x minus the other. Okay, so that's what we're going to do. So I'm going to do top point minus bottom point. So top y minus, what's the bottom y? It's -3. I'm subtracting -3. And then top x minus, and what's the bottom x coordinate? It's -5. Okay, let's take a minute here to think about a negative. So I've got a little number line up here that I want to use to illustrate this. And so distances always come from a subtraction. Always. What's the distance, for instance, from here to here? From 1 to 3. Well, you could say, well, we can look at this and count, but what's the mathematical operation that we're actually doing? Well, we're doing 3 minus 1. That gives us a distance of 2. This is a distance of 2, and we get it from a difference or a subtraction. Subtraction and difference are the same thing. What about this distance? Well, this is from 0 to 3. Well, we would take big number minus little number. There's our distance. So from 0 to 1, we have a distance of 3. But now, what if we have a negative number? Okay, are we going to do the same thing? Well, exactly right. We're going to take big number minus little number. The big number is 3, little number is -1. So we're going to take 3 minus, and the little number is -1. What's the distance going to be? Well, we can count it. We know from -1 to 3, if we just count 1, 2, 3, 4, we know it has to be 4. So 3 minus -1 must be 4. This is a good illustration of the fact that minus minus is the same as a plus. And so this is something you always want to remember. If you subtract a negative, if you minus a minus, it's the same as adding. So let's go back to our problem here. And Now we know that this is really 4 plus 3, and this is 3 plus 5, and that gives us 7/8. Well, there's our slope. Just like we got it visually, here we did it mathematically. Now, one more thing I want to do. I want to show you that because we're doing fractions, it doesn't matter if you subtract this point from this point or this point from this point. So in order to make that case, I'm going to do the other way. So what I did a minute ago, let's see, I did top point minus bottom. Now I'm going to do bottom minus top. So bottom y minus the top y, bottom x minus the top x, and that gives us, okay, well, what's negative 3 minus 4? Well, if you're on a number line at 0 and you go left 3, that's negative 3. And then you go left 4 more. That's what negative 4 means. That's going to put you at negative 7. So negative 3 minus 4 is negative 7. Negative 5 minus 3 is negative 8. And a negative divided by a negative is a positive, which means we can just ignore the negatives, and there's our slope. And you'll see it's the same as this. So if you have the question of, well, which point do I subtract from which? Well, the good news is it doesn't matter. But you need to make sure you go the same way with both of them. If you do top y minus bottom y, you need to do top x minus bottom x. Don't go two different ways or you will have a sign error. Okay, another one here. So let's do it visually. So I'm just going to blow through this kind of quick. Visually, I see that if I'm at this point, so we're going to use these 2 points. If I increase 1, 2, 3, 4, 5, 6, 7, 8 x's, then I'm actually going to lose 4 y's. Okay, what happened to y? Well, y was here at 2 and it dropped to negative 2. Well, a drop is a negative. Y on the vertical y number line, y was at 2 and it went back to negative 2. That's a loss of 4. Okay, a negative divided by a positive is a negative. 4 and 8 reduced to 1/2. And there's our slope. Now let's use the formula. So 1y minus the other over 1x minus the other. Okay, so I guess I'll do this point minus this point, the upper point minus the lower. So upper y minus lower y, upper x minus lower x. So 2 plus 2, negative 3 minus 5, that's going to be 4 over negative 8, and that's going to give us negative 1/2. So the same one. Same slope we got up here visually. One more. So here we don't have a graph at all. We're just given these 2 points and we're told to find the slope. So we need to decide which way do we want to subtract, a left point minus right or right minus left. So it doesn't really matter. I think I'm going to do left minus right. So left y minus right y, left x minus right x. That gives me 5 over 0 minus 1 is negative 1. And a positive divided by a negative is a negative. 5 divided by 1 is just 5. And so our slope is negative 5. Now, let me just close by stating this. A lot of the time your slope is a fraction that's irreducible, but if you happen to get a reducible fraction, say you're doing a slope and you get this. Okay, so this is totally different here. And then it would reduce to 2. So your slope is 2. It's really 2 over 1, but you can either write it as 2 or 2 over 1. If you are graphing a line and you need to use the slope, then you would deliberately make this a fraction, because that would be a good visual demonstration of the fact that if you gain 1x, you're going to gain 2y's.